All right, hello everyone. Welcome to day 3 of Computer Science 41. We're going to talk about the homework assignment that was just due, and we're going to talk about the first competency exam. The second competency exam will go up today. You don't have to take it if you pass the first one. I'll say that again because students always ask me, do I have to? No. If you pass the first one, you don't have to do the retake. That's why it's a retake. You don't have to retake it if you passed it. And passing, it's a 3 out of 4. So if you get a 3 out of 4 better, then in the grade book it'll become a 4 out of 4. And then the retake will open up for people that got a 2, a 1, or a 0. Okay, so let's go over it, and we can talk about it, and maybe learn some stuff. So, preview. All right, so zoom in. Int age equals 0, it inputs age. If age is less than 18, it prints out you're a minor. If your age single equals 18, prints out congratulations, you're an adult now. Also, if age is less than 65, it prints out adult, else out senior citizen. Okay, so this is clearly an if statement that's trying to print out, 4 different things based on your age, right? Whether you're a kid, whether you're a new adult at the age of 18, if you're a normal adult, or if you're a senior citizen. So there's 4 possibilities given. Missing semicolon is not the case because each one of these lines ends in a semicolon. It's all good. A lot of people picked code will not compile without the curly braces, and that is not true. Some people think that, but if you have an if statement and there's one line of code inside of the code block, the curly braces are optional. The curly braces are there to sort of aggregate together multiple lines of code. So if you have multiple lines of code, then the curly braces tell you which parts are associated with the if statement. So the if statement runs everything between the curly braces following it. If you omit the curly braces, then it runs one line of code. Okay, one line and one line only. Exactly one line. All right, so this formatting here is actually fine. I'm sure there's people on the internet that would get mad at me formatting the code like this, but it's readable. You can go through it and read it, and it works a-okay. So you need to use double equals instead of single equals. Yes, this single equals here is the assignment operator. 1 equals is assignment. In other words, it sets age to be 18. It sets the variable to be 18. It's not checking to see if age is 18. It's setting it to be 18, which is very probably what's wrong with it. Okay? It's very unlikely that you're trying to set the age to be 18 every time the person's an adult, because this code wouldn't make any sense. Right? So when I say what's wrong with this code, that means, what's wrong with it. This code will compile, but what's wrong with it? You're not doing bugs. Bugs are more than just compilation bugs. Bugs are more than just compilation bugs. There's bugs that also cause the program to not run as you expect it would, and this would change. These 2 options would never take place because this would be setting the age to be 18. That returns true, and then it'll print congratulations, you're an adult now every time the person's not a minor, and that's 99% guaranteed what you did not want to have happen. All of the else's should be deleted. That would break the code also, because it would print, if the age was 17, it would print both minor and adult, right, and senior citizen if you deleted all the else's. So I don't think you can pick that. Let's see, we can probably do item analysis on this, quiz stats. So let's see how you guys did. So there's the spread on the competency exam. 0, 1, 2, 3, 4. Okay. 2, 3, 4. So yeah. But again, don't worry about it. You can retake it. All right. So 15% of people thought you needed curly braces. All right, suppose you're passing a vector of integers to a function named delete half. and you want the function to delete the last half of the vector. How should you pass the vector to the function? So there's a couple different ways you can pass the vector. You can pass it by value, which makes a copy of the vector, or you can pass it by reference. And these options, const vector, also by value. So these two options here don't pass the vector to it at all. So they're just wrong. Like they're not these functions don't take any parameter at all. So they're both wrong. These two guys are taking the vector by value. And since you might notice the function is not returning anything, it's a void function, it doesn't return any value, the only way that you can delete the second half of the vector is by passing it by reference. When you pass something by reference, then the thing that you pass in can get changed by the function. If you pass in a function by value, it will copy the entire vector, which is almost always wrong. It'll copy the entire vector, it'll delete the second half of the vector, and then when it returns, the vector is unchanged back in main. So it have absolutely no point whatsoever. Okay? So if you're going to pass something to a function and that function is going to change it, you have to pass it by reference. Okay? Like that. I'm making a... Is it volume low? Okay. I can move the mic maybe over here a little bit. Let's see if that helps. You can also try... if you click on me in Discord, you can increase the volume maybe. Okay, I'm making a rational class for holding rational numbers. A rational is a fraction. Hey! Okay, so what's wrong with it? So this class is missing a semicolon at the end of it. Every class definition in C++ must end with a semicolon. It is something that everybody forgets, myself included, especially when I've been doing Java programming. Right, Mr. Beal? Classes in Java don't require the semicolon at the end. The C++ requires a semicolon right here. So 74% of you guys knew about the missing semicolon. That's good. The other problem is that classes, like we talked about last time, classes default to private. And so both of these guys are private. Therefore, this class, which is just going to serve as your plain old data type of class, you know, a fraction basically, can't actually be used by anyone. So there's semicolon. Well done, Connor. Well done. Semicolon. So this class is pointless. Main can't use this. You can make a variable type rational, you just can't do anything with it. And so it's wrong. There's literally no point. And again, there's probably people on the internet that are going to be like, well, you know, if you want to just make sure you're allocating a certain amount of memory, nah, it's pointless. Pointless. Okay. So you can't declare both variables on the same line. That's wrong. You can always do a comma. Whenever you declare a variable, you can do comma and separate multiple variable declarations on the same line. So you say int x comma y comma z. That's fine. There's absolutely nothing wrong with doing it that way. And the name of the class won't compile with a capital R in the name. No. That's, no. That is... yeah. The standard convention is to have a capital letter in class names. So the convention that I use is... so here are people that... Hopefully we picked up your partners here. So like I said, we're running cheat checking, and so it should be picking up the Blancas. And so hopefully those are your partners. So when I make a variable x, y, z like that, I typically use lowercase or team underscore score underscore score. I typically do integers like that in what's called snake case. Snake case. Classes, I typically use camel case like that. And for constants, I use all caps with underscores between them. So, not camel case, sorry, Pascal case. Pascal case. There's only one try on these quizzes, yes, but I will do a new one. There's no point retaking it if you know what the answers are. So the retake will go up later today, and then that will replace the grade on this one. So the way that it works for the competency exams is you can keep taking the competency exams over and over again. They're different every time, but the highest grade you get replaces your previous grades. And if you get a 3, I bump you up to a 4 because it's basically pass, no pass. So you don't have to retake it if you got a 3 out of 4. It's fine. Okay, and then for this one was the hardest one, and it's because you have to write your own code. As I'm sure you're aware, writing code is harder than reading code, and multiple choice is easier than free response, right? And so 45% of students got this one wrong. And I will just, one funny thing was that, here, let me read it. Write a some code. So, sorry, that was a typo. Write some code that will read from the keyboard into a vector of integers named vec until the user types 0. 0 should not be added to the vector. So some people thought this meant until the user types that, which is the emoji, right? Until the user types 0. 0 should not be added to the vector. Assume you're inside main. Header files are already included. Vec has not been declared, so you have to declare vec. Some people didn't do that. And okay, so let's show you the answer. CC then main2.cc. Vector of ints named vec. So some people wrote, we didn't learn vecs in our class. So here's your introduction to vectors. And why are you complaining about this? No template named vector. Did you mean std vector? Oh, yeah, okay. See what I mean? See, that just ate up like 4 or 5 seconds of my life. And all these people are like, oh, we love STDs. It's like, add up all the different, hours of my life that were spent from like, std not being declared. No, it's just funny. I don't think I marked anyone down for misreading the 0.0 thing, but it was kind of funny. Like some people were like reading a string, and then if the string matches 0.0, then they break, and then they S2I it into an integer. Like I was impressed. I didn't mark anyone down for that. Okay, my hatred towards STDs. I don't hate STDs. I just think they're wasteful. Okay. Vector int vec. All right. So that is how you make a vector. So for those of you that have not studied vectors before, they are the better way of doing an array. So a lot of people learned how to make an array like this, right? So this creates 100 integers named R0 to R99. Okay. So this is like what is classically taught in C++. You make an array that makes 100 integers. The same thing, the equivalent of that using a vector would be this. Okay, so this means a vector of ints named vec of size 100. And so this creates 100 integers named vec .0 to vec .@99. Okay. Technically, you can use square brackets with vectors, but I don't teach it that way because I teach you guys the safe way first. And so the safe way is this, using .at to access elements of it. And that will do bounds checking. So if you go out of bounds, then it will throw an exception, and you will know that you went out of bounds. With an array, cout array 101. Right? So that is going to be reading, or even worse, array 101 equals 42. You can read and write to an array outside of its memory region. And that's really, really bad. This has been the source of more bugs than literally anything else in the history of mankind. Really, since caveman days. Like, I'm actually being serious here. Since caveman days, this thing right here has caused more serious bugs than anything else. The cavemen didn't have any bugs, so it's true. Since caveman days, this is the most problematic. Arrays are what took out the dinosaurs. And so yeah, this code will compile, and the compiler, if I'm smart about it, main2.cc, it'll ranges node compiles just fine. Look, oh no, main main2, there we go, and look, it works. I wrote 42 to array element 101, and it printed it out. No harm, no foul, man. Yeah, I just overwrote some random address in memory. And maybe that random address in memory had my credit card number in it. Maybe it had my social security number in it. My bank account balance in it. My bank account balance is now 42. You know, like, no, this is really dangerous, you know? Really, really dangerous. So, I only teach arrays to my students so that they can recognize them when other people use them. I don't think you should use arrays ever. Ever. There are niche uses for them, but where you're at right now, no. Don't ever use, just as a general rule of thumb, just don't ever use an array. And your life will be much better. Your spine will get straighter, your muscles will get bigger, you'll grow facial hair. Sorry for the women, but so yeah, don't use arrays. Okay. So so use a vector instead. Okay, vectors are just better in every front. They're better. For example, with an array, put these guys back. With an array, void Bob and pointer array, cout array 42. So arrays are basically behind the scenes. They're just a pointer. They're just a memory address. An array is just a pointer, and it's a pointer to the first element of this chunk of memory. And so when you pass it to a function, it's really just a pointer. And you don't know how big this array is, right? And so this function might think it's being all cool and stuff, printing out element 101, but it doesn't know how big this array is. Pointers don't have any size information on them. A pointer is just a memory address to the first element in the array. And so this code will compile and it will run. And it prints 42, but it's overwriting memory. It's overwriting some other variable probably. Who knows? Vectors are not as fast yet. Don't worry about speed in this class. Here's the thing, like if you need speed, you probably don't. Like, let me just put it that way. Like, if you're preferring this over this because of speed, Bjarne Strustrup always says, well, what optimization flag are you compiling your code with? And they said, what's an optimization flag? Right? And it's like turning on the optimizer will do far more to speed up your code than switching out a vector for an int array, right? Yeah. This does have a heap allocation. It will do a call to new behind the scenes and will allocate memory, and it will initialize all the memory. Whereas this does not initialize anything. In fact, if we printed out all the elements in the array for int x in array, I wonder if that would work. I don't think it will. Maybe it will work. Cout x. Let's see if it's fine. Cool. So you can see that the array is full of uninitialized values. This is what RAM looks like when your code's called. filled with random numbers. Vectors cannot be uninitialized. Vectors will always initialize all the values to 0. And so yeah, it's slower. It is slower. It's also safer. And yeah, so if you ever get to the point where you've turned on the optimizer, and you've optimized your code, and you're in a really hot loop that runs millions of times a second, then you can demonstrate to me that a benchmark will give you better performance with an array than a vector, then by all means I will give you permission to use an array in that case. But from a CSCI 40 student point of view, it is garbage. It's garbage. It doesn't include size information with it. There's no way for this function to know what size it is. So what a lot of people do is they'll pass in a size separately. And then they'll do something like this for size key I equals 0, I is less than size, I plus plus. Do that. And we'll now call this print array. And in any case, if you do get to that level of like switching out a vector for an array, there's actually the array class that you should use anyway, which in C++ looks like this. So if you really do need the speed, use a C++ style array class, not a C style array. Period. There's literally no reason to use a C style array, like basically ever. C++ style arrays, which look like this, they have their size information on them. There. So I call print array, and it's going to pass the pointer in, it's going to pass the size in, and then it's going to loop through the array and print everything out. Why use square brackets for arrays? What difference does the square bracket do for you? The square bracket does not. The square bracket does no type checking, or it does no bounds checking. Sorry. And so you can see there you go. There's RAM. Okay. So like if you wanted to access vector element 5, you can say vector.at 5 is equal to 42. Another way you can do that, Miss Crump, is by doing it like this. This bounds checks your code. This does not do any bounds checking. Okay. And so where you at in CSCI 40, you should always be bounds checking your code. And if you ever, again, get to the point where you're like, oh, my performance isn't good enough, then switch this line of code out for this line of code once you're very, very confident that your code is not going out of bounds. And history has proven that programmers are really bad at making sure their code doesn't go out of bounds. For example, last semester we did an assignment where you're reading through an array and you have to grab a value above. It's a 2D array, and you have to grab a value above, below, left, and right. Every time you hit an edge, there's a possibility you're going to go out of bounds. If you're on the top row, you can go out of bounds above. If you're on the bottom row, you can go out of bounds below. And programmers are really bad at finding it, at least the first 20 times they code it. After you get some experience, then I would still write it this way first, and then after I'm like, okay, it seems to be working, then switch it out if I need the speed. Okay. What happens if it does go out of bounds? Good question. So let's switch this out with vector.at 100. Actually, let's start by just doing this, right? So I'm going to set vector element 100, which is out of bounds, right? This is something that a lot of people don't realize. If you have 100 elements, they go from 0 to 99. This is out of bounds. A lot of people don't realize that. So you can see that it prints out 42 there. Okay. So I'm just going to go ahead and delete the square bracket array. Get rid of this nonsense. You have no guarantee that this size is correct. right? So your function might be going out of bounds just because somebody passes in the wrong size, right? Just don't do that. Okay, so yeah, so this code print out 42. It went out of bounds. This is really bad. Proper way of doing it is this, using .at, vector.at 100, set it equal to 42. And this is what happens if you go out of bounds. It kills your program. You might think to yourself, wait. Isn't crashing bad? No. Yes, but no. Best option, your code works. Second best option, your code crashes reliably. The horrible third option is your code silently corrupts memory and you have no idea where, and you write to element 100 somewhere, and then 10 hours later you try reading your bank account balance, it's set to 42, and you have absolutely no idea how it got set to be 42. And then you spend the next 2 weeks of your life going through every single square bracket in your code, trying to find the one place where it goes one element too far out of boundaries and is corrupting memory. Like there's a reason why I have a bald spot here. This bald spot is from me tearing out my hair, tracking down these bugs back in the day because I was coding in a world before vectors. It's really, really garbage, trust me. On a small project like this, it's like there's 4 lines of code. You can look at the 4 lines and figure out which one is causing the problem. You know what I mean? When you've got a million lines of code in your code base, you just have to so there are tools that help for that now. Also, you guys are living in a very lucky time to be alive, believe it or not. Even though there's a pandemic, you guys are actually living in a pretty nice era, because there's now tools that will catch this kind of stuff. So if I run it, it's corrupting memory, but you might notice that I've been putting that backslash. You see I've got that backslash in front of the G++. I'm doing that because by default, I've got turned on something called address sanitizer. Address sanitizer makes sure that you don't corrupt memory. Watch. Boom. See that? So, actually, that wasn't even address sanitizer. That was because I have the safe C++ library turned on. So I've got multiple safety levels and multiple safety checks turned on by default. And so the safe vector library said, error, you tried accessing something with index 100, but the container only holds 100 elements, and it shows you, you crashed and all this kind of stuff. Okay, so it's really nice. Address sanitizer also works with square bracket arrays and R100, R1010 is equal to 10. So if I just compiled this normally, G++ main2.cc, then you'll see address sanitizer throw a report. You tried accessing index 1010, which is out of bounds. You went out of bounds here. Yeah, so address sanitizer, it tells you which line of code. Main2.cc, line 9, character 10. Do you guys see that? This is actually really important. Most error messages look like this. It's the file name, line name, and character name. File, what file you're in, what line, what character. It'll pinpoint exactly where in your code you done goofed. Okay, you done goofed. And so line 9, yep, 10 characters to the right there. Boom. That's where you screwed up. You screwed up bad. All right. So, like I said, I've got multiple levels of security, and all of these are turned on by default for you. On top of that, I've got, actually, let me put these things back. On top of that, I've got the compile shell script. I've layered like 4 levels of safety onto this server because new programmers screw up all the time with this kind of stuff. All right, so about there. Okay, so CPP check is tool by Google, and CPP check determines at compile time that you went out of bounds. Do you see that? And then the compiler determines you went out of bounds, right? And so with all the different levels of warnings and safety and pre-checks and all this kind of stuff, my goal is to make these kinds of mistakes a thing of the past. And use vectors also. Use vectors. Am I not streaming to YouTube? I am streaming on YouTube right now. Let's see if I can find YouTube. Stream is full. I see. Having trouble finding YouTube. That's not good. There we go. All right. And YouTube Studio. Content. Live. Where is the... Where do you watch yourself live? Like, this is the dumbest thing. Okay, there we go. Get a link to this. Where is the link? Copy video URL. Okay, there you go. There you go. Title's wrong, but okay, whatever. Okay. Continuing on with my rant about safety. Yeah, so don't use square brackets. Students worry way too much about speed when they're starting to program. And the reality of the situation is usually 99% of the time it doesn't matter. Once your program is like running and it's running too slowly, then you can worry about it. So there's something called premature optimization. It's a problem that plagues a lot of programmers, premature optimization. They try worrying too early on, I'm going to make this fast, and then their code corrupts memory, and then they, waste so much time trying to figure out why, and usually they can't figure it out, and they get frustrated and quit. Okay, so vectors. The way that I usually do a vector, though, is I don't give it a size at all. So this creates a vector of size 0. Vector of size 0, which you would think is useless. And, kind of is, I guess, if there's no way of growing it. But one of the reasons why vectors are super amaze is that, unlike an array, they can grow. Arrays are fixed size. Arrays have no size information on them, so you can't tell how big they are. Vectors, it has that. Vectors can grow. Vectors can allocate their own memory and deallocate their own memory. You can't memory leak with a vector. So, IMP'd. I'm speed. So, vector of size 0. All right. So, while true, so we want to write code, read data from keyboard, read data from keyboard until 0 is read. Read data from keyboard into vec until 0 is read. This was your assignment. Okay, so you're going to read data from the keyboard into the vector until 0 is read, and 0 does not go into the vector. So int x equals 0. Into x. If x is 0, break. So break will terminate a loop that you're within, and so it doesn't quit the program. Some people did return, like we're just going to quit the program. No, you probably don't want to just quit the program. Break just ends the loop, and so you don't need this line down here. But like when break is called, it's going to come down here and print done, right? That's what break does. Break doesn't quit the program, it just ends the loop that you're in. It jumps to the closed curly brace and keeps going. Okay. And then if you want to grow a vector, this is something you guys have to know. You have to know, you have to know, you have to know. It's called pushback. And so pushback will increase the size of the vector by 1. And so it writes an integer into the end of the vector. Okay. Like that. And that's all you had to do for the competency exam. So make a vector of integers, read from the keyboard one int at a time. If the int is 0, you break. Otherwise, you add it to the vector. Okay. A lot of people did more complicated stuff, and I read every single one of them. And if the logic was correct, I gave you full points. If the logic was not correct, I gave you 0 points. It's pretty simple. Can you ever push back multiple things at a time? No, but there's standard library functions like copy. Like if you want to copy a chunk of one vector into another vector, there's std copy. When you make a vector, you can set one vector equal to another vector, and it'll copy all the elements from one vector into another vector. There's ways and means of doing basically anything you can think of. But pushback just takes one element. I think it was some of them, like some of the string operations, like you can do repeated string operations and things like that. But basically, it's used to grow up one element. Okay. So if I wanted to be super cool hacker dude, which I sometimes do when I'm not trying to confuse students. In C and C++, 0 is false, right? 0 in C and C++, 0 means false, and anything else is true. A lot of people think 1 means true. No, anything else is true. Anything else, anything not equal to 0 is true. So -1 is true, -200 is true, 500 is true, 1 is true. And so a very common idiom that people use is, rather than saying if x equals 0, you could just say if not x. If not x. So if x is 0, 0 is false, not x is true. It'll break. So if x is 0, the expression here evaluates to true, and then it calls break. Yeah, a lot of people made a variable out here, like they made int x out here. I don't think it's necessary. I personally wouldn't. Another thing you might do, if you want to use my read library, which all the cool kids are doing these days, I hear, is you can combine these two lines of code into one. Like that. And so that will read an integer into x. What color scheme am I using? I think I'm using Kohler. Solarized, sorry. Solarized. Good question. Desert, I like Desert, except on 24-bit color, they decided for whatever reason to give the background this light gray color that kind of burns my eyes a little bit. I don't know. Like I like Desert, but only in 8-bit mode. In 24-bit mode, that kind of gray, the gray kind of background kind of bugs me a little bit. And I use Kohler a lot as well. Solarized is pretty close to Kohler, except the white text becomes like a light gray instead. So it's a little bit softer on the eyes. Grove box. I don't know if I have it. Yeah, I don't have that installed. Okay. Are you penalized for square brackets? No. Like, because I understand that most professors teach square brackets still, and that's fine. It's just a personal quirk that I have that I just it's not even a quirk, I would say. It's just based on 20 or 30 years of experience in working professionally with C++ and teaching it professionally is and looking at bug defect reports and things like that. Square bracket arrays are just garbage. I'm just gonna say that. Like in my opinion, like the compiler should throw a warning if you use a square bracket array. And again, there's people on the internet that are like, but how else are you gonna do these low level things? And it's like, yeah, fine, okay, sure, don't make it a warning. But for my students, I've been thinking about making it an easy peasy, so it throws a warning like, don't do this. Use vector, or if you need to, use an array, the array class. Okay. So vectors, the way that I usually do vectors is I start at size 0 and I grow them. I grow them as I read them. One of the big problems with arrays, again, square bracket arrays, is that you have to guess. You have to guess how many elements you're going to have, right? It drives me crazy, like coding competitions. Like in coding competitions, or like Code Wars and these other sites, they'll tell you up front, like, you're going to be reading in 50 price numbers. You're like, okay, cool. In real life, you have no idea how many price data points you're going to be processing, right? Like if you're going to be trying to figure out if Vons or Save Mart is cheaper, right? And you're going to be having mystery shoppers going there and buying peanut butter at the two stores. You're going to need two different arrays, whichever you're using. But if you're using an array, you don't know how big the damn array should be, right? Because like, how many items are the mystery shoppers going to shop for? I don't know. 10, 100, 1,000? Probably not 1,000,000. But like maybe, like if this becomes like a nationwide thing where like people are entering things from all over, maybe, like WalkerBot wasn't working because he set his array size to 350 and that wasn't enough to pick up all of your guys chatting. So, with an array, you just have to guess. And you're like, all right, well, I'll just make it really big so that we'll never run out of room. Well, okay, cool. Now, let's calculate how much RAM you just wasted. You know what I mean? Like, so you just made 1,000,000 elements. So you're using 4 megs of RAM to hold 10 integers. Use a vector. Use a vector, and the vector will grow the array, and they will waste a little bit of memory because vectors double in size. Every time you run out of room in a vector, it doubles in size and copies the data over. There's other ways of doing it, but that's kind of the basic way. And so vectors might waste half the RAM, but when you do an array, usually people make them really, really big just because they don't want to deal with running out of room. And then every time they do something with it, they have to check to see if there's room left. And if there's no room left, they have to handle that somehow or just kill the program. Whereas with vectors, it's you just use pushback, right? And it just grows up to the size of RAM in your machine, which nowadays are pretty good. So most people that do arrays just grossly over-allocate RAM just so they don't have to worry about running out of it. And then you end up with Google Chrome, right? Yeah. Will you be using Code Wars modules for future assignments as well? Maybe. I liked this one. All right. So, mystery shopper tried to use it a bunch of gift cards. That's funny. Yeah, the gift card scammers are getting creative. Like they go through the our college website and they figure out who the president is, and then they mail the professor saying, "Hey, this is your college president, Lori Bennett. I'm in a meeting right now, and I need to buy something real fast. So could you please pick up a $100 Apple gift card or Amazon gift card? Either one's fine. I don't care. And email it to me at this address." It's my personal email. Don't worry about it. They do that all the time. All the time. It's crazy. Would it be better to use dynamic memory allocation for arrays? Well, kind of. But do you know in advance how big your array is going to be? It's the same problem, right? Oh yeah, and so there's another issue, right? Whereas if you go int array like this, all right, that's 400 megs of RAM, right? So it's 100 million integers, 400 megs of RAM. Let's see how that works out for them. Crash. 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 That's too big. That's too big. Okay. So you have to use dynamic memory instead. Stack space on our server is not big enough to hold 400 megs like that. So you have to do an int pointer array equals new int square bracket 100 million. Like that. And that works just fine. Okay. So, but even though that works just fine, you still have to guess how much memory you need. You know what I mean? And so, like, if you run out of memory, it's like, okay, you can delete the array and make it, or sorry, you duplicate the array, copy all the elements over, and delete the old array. But guess what? Guess what? That's what a vector is. That's literally what a vector is. A vector is like, I ran out of room, I'm going to make a new array, I'm going to copy all the elements over, and I'm going to delete the old array. You could do that by hand, but why? But why would you? Why would you do that? Why would you do that to yourself? In my opinion, no news is good news, right? So there's a talk on that, literally called No News is Good News. And so if you write modern C++, C++ 2011 and above, you can literally spend most of your life not ever calling new. So in this class, you will, because you're going to be making the data structures. So vector is a data structure. A data structure is something that holds lots of variables, right? In this case, it holds a lot of integers, let's say. This is a data structure. This holds 100 million integers. Okay? And so when you're making data structures, you kind of have to know pointers and newing and deleting and stuff like that. We'll get into that. But in like my normal programming life, hell no, dude. I use a standard library. The standard library gives you the tools you need to succeed. It's like reading. In elementary school, they're always like, reading is the skill you need to succeed. Tijuana brass gets louder. Yeah. Put in more effort. Why? Why would you do that? Yeah. So, yeah, vectors are cool. And in this class, we're going to be learning lots of new data structures. You might have noticed it in Web Advisor. The name of the class may be data structures, So we're going to learn about all the different kinds of data structures that are in the standard library. You're going to make some of them yourself. So you kind of, when you make something, you kind of understand it from the inside. And you kind of get what's going on a little better. You'll learn when to use a data structure, when not to use a data structure, what data structures are best at what jobs. And these are kind of like the vocabulary you need to be a good programmer, right? Like I was watching some computational geometry stuff last night, as you do for fun with my daughter. And Ada, what is a convex hull? It's like the outline of points. I'm like, yeah, that's what a convex hull is. Yeah, good. She hates programming, by the way. I don't know if she hates it, but she does not enjoy it. So I doubt she's going to become a computer science person like her dad, but she seems to get it pretty quickly. So I don't know. She's like 8. Yeah. See, convex hull sounds really complicated, right? Convex hull. The hell is a hull? Isn't that like on a ship? And it's convex? Like, what the hell does that mean? I will give you guys some insight into academia. Academics love using words that normal people don't understand because it makes us feel smart. Like, I could talk about like the outline of points, but why would I? Then I wouldn't feel smart. If I use language that 8-year-olds can understand, then I'm not smart. And I need to be smart. So I'm going to call that a convex hull, and you're going to like it. What I realized about math is that it's mostly things that are pretty easy to understand that are made way harder to understand than kind of the maybe should be. Like, man, what is it, like hat notation? Like these things just look like, that looks like the language used in the Lord of the Rings. Like the dark tongue. They have these like carrots over the letters and all this kind of stuff. And I don't know. It's just a thing. Like you might notice that I don't like using lingo. I don't like, and when I do use a term like data structure, like I explain it. A data structure is just something that holds lots of variables, because that's literally all it is. If you need to keep track of 1 million integers, you need a data structure, because ain't nobody got time to do this. You know what I mean? X, Y, Z, W, A, B, C, D. Nobody got time to make 1 million of those, right? So you need a data structure. That's all a data structure is. A data structure is a bunch of variables made at once, or maybe not at once, like a pushback. Okay. So, convex hull, H-U-L-L. Yeah. Use terms like arbitrary. No, the best is when like some of my math professors would be like, and I'll leave the remainder of the proof up to you. It's like, but you're the instructor. Like, please. Like, I was following along, and then you just stop. Like, no, I'll leave the rest up to you. I'm like, no. Like, I need you to explain this to me, please. The textbook has the proof. Just read the textbook. All right, so that was the competency exam. I'll put up another one tonight. You might notice there's only one participation grade so far. That's because we're having issues with the attendance spot. So just be patient. Don't worry about it for now. Sometimes I use big words I don't fully understand in order to make myself sound more photosynthesis. Woo! Look at that. Okay. All right, so let's do a code review. Let's find somebody's code that did okay on it. So CSCI 41, Spring 21, CD fractions, then grade file. I'm not showing anything right now because it's got grades on it. Grade file? Oh, grade file. So let's find somebody that got like an 8. Let's see if we can find somebody with an 8. No, that's their username. 8. There we go. So let's look at who's on Discord right now. Let's see if they're there. Sayer or Selway. All right, let's do Selway. All right. So, Selway, how you doing, man? Go ahead and unmute yourself. Do a code review. All right, Selway, can you hear me?
Yeah.
Can you hear me? Excellent. Time for a code review. So this is not worth any points, so you're lucky. Wait, no. Whatever. This is Selway and Alfaro. I think Fernando dropped the class. He lost contact and left the Discord. Unlucky. Oh, you've got the mouse support still turned on. Okay. See, I like selecting code without moving the cursor. That's why I don't use mouse mode, because I like to be able to select things without the cursor moving. But you do you.
Oh, okay.
If you guys ever want to turn off mouse support, your vimrc file, that line of code right there, disable it. Just put a little comment in front of it. All right. So let's first of all run the input tester, see how you did. Timed out? No? Yeah, timed out. And test 9 failed. Okay. All right. The professor is muted. I'm muted? Primrose Everdeen. You are tribute. Okay. All right, so let's take a look here. So please enter the numerator, you read in a string, and then you go through the string. Aha! Yeah, so that's why you're failing the last test case. The last test case has a bad input for the numerator, but not for the denominator. And so you're supposed to die after reading both numbers in. Okay?
Oh, okay.
So all you have to do is, what's that, 4 lines, D4D, and pasty paste with a P. And then save, compile, run. You're still going to time out on test 5, and you passed test 9 now. So congratulations. Okay.
Yeah.
So you understand? So the thing was printing, please enter the denominator, and you're probably like, why am I failing that? Well, you gotta if you're failing a test case, you're not really sure why. That file there, you can view, you can vim it, vim, right click, and you can see what the input is, like that.
Oh, okay.
And then you can look at the output, vim, or some people like catting it, cat dumps it to the console. So cat it, and it will show you that the output is this. Okay, and so when you run your code and you type in -3 and 3.1, you need to make sure that the output matches the output that's supposed to be there. And your code was printing this one, but not that one. And that's what the line above was telling you. The line above was showing you that the reference implementation, mine, was printing that to the screen, but yours was printing it to the screen, but mine wasn't. That's why there's that little diff arrow there. That's the one line of code difference between your code and mine. Okay, and so just open these files. You just type it in manually and look at the difference and deduce what's going on from that.
Alrighty.
Diff with the Y tag on helps as well. Kearney cut out for me just now. Code was much shorter than mine. I made a whole class for fractions and overloaded operators to compare them. Yeah, that's cool. That's what I did the second time I implemented it. All right, so main.cc. Yeah, so this assignment was adapted from codewars.com. I was doing a lot of the coding assignments on there over the winter break to keep my skills up, and a student asked, "Are you going to do that again?" And I don't know, maybe. Some of them were cool. They're ranked by difficulty, and so this was a rank 5. So 9's the easiest, 1 is the hardest. I guess maybe there's something harder than 1, but this is like kind of a moderate difficulty problem on there, because I think a lot of you guys saw like the math of it isn't immediately like I hadn't done fractions in a while. Right? Is that what happened to you, Selway? Like, were you like trying to figure out the math for fractions?
Yes.
And it hurts, doesn't it? Like, doesn't it like kind of hurt your brain?
Yeah.
Yeah. Yeah.
A lot.
Hurt my brain too. And it was just funny because my daughter's literally learning this right now, and I was like, all right, I'm going to give them fractions because, you know, are you smarter than a 3rd grader? Is there a reason for not calling die after the numerator? The reason is I deliberately put it that way to see if you guys could figure out what I was doing. I originally had it after the numerator, but I moved it after the denominator because I wanted you guys to see if you could identify the difference between your program and mine. Because my code is correct. My code is correct. By definition, my code is correct. Okay, so one thing, Selway, that you want to do is you want to reformat your code. Do you know how to do that?
Uh-huh.
It's like you're
I
formatting
thought
your
there was a Vim shortcut, but I forgot.
Your formatting's all jacked. So in Vim, the command to reformat is GG equals capital G. Good game, right? GG equals capital G. And all that means, GG, lowercase gg, takes you to the top of a file. Capital G takes you to the bottom of a file.
Mm-hmm.
Okay, so lowercase gg, top of the file. Capital G, lowercase, bottom of the file. And then the equals command is the reformat command. So if I want to reformat just like 4 lines of code, I could go 4 equals equals, and that'll reformat those 4 lines. But GG equals capital G reformats the entire file, and then you can see your code actually looks a lot nicer that way.
Yeah.
It's a lot more readable when it's indented properly. And so let's go through this. So you're going through every character. If it's not a digit, you're dying. So that was the approach I showed you guys last time.
Yeah.
And if the string equals 0, you're going to die also. That works. And then you're converting. I did it after converting it to an integer, but it literally doesn't matter. When I use it multiple times, there ends up being a ton of spaces. There's also the reformat command. So reformat main.cc. That will also reformat your code. And so if you don't remember GG equals capital G, reformat is your friend. Okay? And if you guys use the compile shell script, it reformats your code for you every time. So you don't end up with ugly code. Okay, so why did you use a 64-bit integer instead of a normal integer?
So that I can read the big numbers.
So you could read the big numbers. And what is stol?
That's string to long.
What is a long?
It's so that you can input larger numbers.
Yeah, a long is a 64-bit number.
Yeah.
So one of the test cases has a number that's bigger than maxint, and I did that deliberately. Like I said, most of the test cases were pretty straightforward, but I sprinkled some pixie dust on these to make them a little spicy. A little bit of chili powder on it. It is a 64-bit integer. And so what is int 64t?
It's saying that's going to be a 64-bit int.
Mm-hmm. And that's basically the same thing as that, right?
Yeah.
I like using this format better. I actually have, in my professional practice, I almost always specify the number of bits, like every time. And the reason for that is because I don't want to be unpleasantly surprised when I move from one platform to another. Do you understand?
Mm.
Do you know how many bits an int is, Mr. Selway? How many bits is an int?
By default?
What's the default?
Starts at 32, right?
What's the default?
I don't know.
Yeah, that's the problem. Is that ints actually are not 32 bits in the standard. The people assume ints are 32 bits because on most modern platforms they are. But if you move to a 16-bit system, your ints will become 16 bits, maybe. And that maybe thing is what worries the hell out of me. Because one of my jobs, Mr. Selway, is I used to port things between different obscure platforms. And so I was paid to take working C++ code and turn it into C code, which is opposite normal, normal things. But I took C++ code, converted it to C to make it run on this obscure Texas Instruments digital signal processor, right? That only accepted C as the input. And DSPs, digital signal processors, sometimes their chars are 256 bits. That's allowed. And maybe your int is 16 bits, and maybe your int is 32 bits. You don't know. And so when you write your code, I tend not to use things like long anymore. I will specify it manually, like this.
Okay.
And so the way that you did it was on point. It was good. It was good the way that you did it. One thing that I will do very commonly is I'll do something like this using u64 equals u int 64t, because I kind of get tired of typing. That's an unsigned 64-bit integer. Unsigned means there's no negative numbers, right? And so I get tired of typing those things, and so I'll typically alias them. So what this is a type alias, right? And so basically I could just make a variable like u64x. Do you understand?
Alright. Yeah.
Yeah. And so that, or if I wanted to do a signed integer, I'd do I64 like that. And then in your code you could be like I64. So I'll oftentimes do things like that just to make it a little more compact.
Okay.
So what's the difference between long and int64t? Yeah, they're the same thing. I don't think longs can be anything other than 64 bits. In my opinion, they need to have support for bigger integers, honestly. Long takes 64. Long is 128. Interesting. Okay. Interesting. Long is not part of the C++ standard? Oh, that was 2009. Who knows? Okay. So, yeah. So I use things like this every time. So good. Well, good on you. All right. Let's see what else we got here. int64. Yeah, you could alias it to int64 if you want. But the only advantage there is an int is that it's 3 letters. You know what I mean? And so I'll use I32 to mean a 32-bit int. I16. Okay, so what do we got here? If x equals 1, you're going to output the curly boy, and you're done, right?
Yeah.
So if the fraction is a 1, you just finish. Okay. If x is greater than y, what does it mean when x is greater than y?
So if the numerator is larger than the denominator, then it's going to go do the rest of the code, which simplifies it.
Yeah, so if x is greater than y, then it's a whole number, and you need to print the whole number. The whole number doesn't have a fraction on it, right? So it needs to be special cased out. You can't use this code with a whole number.
Yeah.
And then use modulus to figure out what the remainder is, and you do some algebra. Okay. And then here is your for loop. Okay, so explain to me what you're doing here.
So that for loop adds 1 to the denominator every loop.
Mm-hmm.
And then the if statement, the code in the if statement finds common denominators, and it checks for the output. And then if it's done, it stops. And if it needs to keep going, then it starts subtracting from the old fraction.
Looks good. Very compact. I like it. Yeah. Cool. A round of applause for Mr. Selway, everyone. So if you guys didn't, and Selway, I'm going to give you that extra point. The reason why your code's timing out is because you're not detecting a 1 in the numerator.
Oh, okay.
So one of the inputs is something like this. It's 1 over like some large number, and it might be because you're not reducing the fractions either. Is maybe why. So it's a very large fraction that when you reduce it, it's 1 over some big number, and so your code's trying to count up to like 100 billion or something. I don't know what it is, and it never gets there because it gets killed by the timeout process. So some students were like, increase the timeout number. No, increase your code. Okay, so I will give you the point for the error message. Okay, so hopefully you guys learned some stuff today. We got 13 minutes left, so let's talk about classes. we're not quite at the point. I wanted to give you guys a new homework assignment today. Unfortunately, there's not enough time to go over that and what I want to cover, so we'll just talk about classes. Okay. Where do you go to check your grade on Canvas? If you're on the server, you can type Alpine. Alpine will tell you what your grade is. It's the email system on the server. But it'll be up on Canvas as soon as class is over. Okay. So let's talk about classes. So if we've been working on making this fraction class, right? And so to do a class properly, again, there's nothing wrong with plain old data. Honestly, there's nothing wrong with it. OOP guys, object-oriented programming guys will be like, no, you can't. Whatever, I don't care. I'm a lover, not a hater. You know, like if you want to code using pods, go for it. If you want to code using OOP, go for it. If you want to code in Java, go for it. If you want to code in JavaScript, get the hell out of here. I'm kidding. But seriously, JavaScript sucks. Okay. So, I don't know if Nate's still here. He's been complaining about JavaScript. Okay, so here we have a class. So this class is defining a new type, and it's going to define what does it mean to be a fraction. And so as of right now, we cannot print this fraction to the screen, right? If we, I want to code in HTML, right? So do you see how like we're kind of half-assed printing it right now? Like every time we're trying to print the fraction, it's like we grab the numerator, we print a slash, we grab the denominator, and we're sort of doing that every time, and this would get really annoying really fast. What would be really nice is if we could just see out F. And in C++, you can teach C++ to see out classes if you want. And you do so by doing this. I'm just going to type it, and then you guys can like, I don't know. I'll copy it onto Discord so you can make a copy for yourself. So the double left arrow operator is used here, right? So the double left arrow operator is the operator that is called when you see out something. It's see out double left arrow. It's the stream extraction operator. See how I don't use jargon? If I want to confuse you guys, it's a stream extraction operator. It's double left arrow. Who cares? Double S then. Okay. My actual name is Dr. Gordon Freeman, PhD in theoretical physics. Keep talking that way, Muya. You're going to create a resonance cascade. We can't have that in here. Okay. So we're going to try and print a fraction f, and this I'll do it properly. And you can ask what this stuff means in just 1 second. So basically, operator. You can create operators. So what is an operator? Like in math, an operator would be like 2 plus 3, right? The operator is plus. And so in C++, you can define operators for your classes. So we could define the plus operator for fractions. We can define the minus operator. What does it mean to add 2 fractions? What does it mean to subtract 2 fractions? And multiply and divide. And I don't know if modulus makes sense. I don't think it makes sense. But an operator is like that plus there. And so if you wanted to make it possible to like say f is equal to f plus f, you see that won't compile right now? That's because there's no operator function defined. There's no operator function defined. And if I were to try to see out f, which is what I'm working on right now, it will work. Why? Because I have defined a double left arrow operator. That's the double left arrow operator. On the left-hand side of it, on the left-hand side of the operator, is an O stream. That's the type of cout. It's an O stream, an output stream. That's the type. And if it looks ugly, well, you're probably right. The output stream is on the left-hand side. There is a fraction on the right-hand side. And so C++ looks at this and says, do I know what happens when there's a double left arrow operator with an O stream on the left-hand side and a fraction on the right-hand side? Yes, I do. And so it'll call that function. Right now, this function does nothing, so it'll be kind of pointless. So let's do something. And so all I'm going to do is that. So I'm just going to actually just copy and paste the code there. Delete word, delete word. Okay. And what are you complaining about? Function's not marked const. Aha. We'll explain what this means at a later date. Okay, so okay. So this is what an output operator looks like. It takes an O stream on the left hand side. It takes a fraction on the right hand side. There was a moment of problem there because I made this a constant, and constant variables can only have constant methods called on them. And so what the hell is a constant method? Do you see how I just added this up here to fix it? A constant method is a method that does not change the class. This does not change the class at all. And so, but I hadn't put the const keyword there, and so it was not compiling. Constant variables like that can only have constant methods called on them. And so I fixed it. Basically, anytime you have a member function, here's a rule of thumb. Anytime you have a member function that doesn't change the class, give it the const keyword like that. And it goes after the function name, which looks a little weird. Okay. So set functions change it, right? Set functions change it so they can't be const. But get functions should basically always be const, right? Unless you're doing something really weird. Your get function should not be changing the class, right? So here is what looks like a little bit of spaghetti, but it's pretty straightforward. Basically, it's saying if you ever see, this is teaching C++, if you ever see this operator like that, and on the left-hand side of the operator, there's an O stream, and on the right-hand side, there's a fraction, call this function. And so it's going to call the function, and it's going to write to that output stream, whatever it is. It's going to write the numerator, followed by a slash, followed by the denominator, and I'm not going to put the end line in here anymore. So it's just going to print the fraction to the screen. Okay. And then I can write code like that. Do you guys see how, even though the operator itself is kind of ugly, do you see how, like, down here in main, it's pretty clean, right? Like now, but now, like, you can just see out the fraction, right? Muya, I'm not going to show your class because I might have them make the fraction class for the next assignment. So I don't want to show too much. But, like, do you guys agree? Like, you can just print a fraction now, and if we compile this, wrong main. If we compile it and run it, you see how it, you know. So do you guys see that? Like, you can just see it out. And so now, we got 4 minutes left. Let's talk about friends, maybe. Do you guys want to know about friends? Do you guys know friendship is magic? Do you guys know about friends? Do you guys know what Friends do? TV show? You know Friends? It's Ross and Rachel and Joey and Chandler. Monica. Phoebe. So this thing here works fine. However, sometimes when you're doing like an output operator like that, sometimes you need to get at somebody's privates, right? So sometimes you need to like output like a private variable. And if you look at this right now, you see how it's not compiling? It says you cannot print numerator and denominator because it's a private member of fraction. You guys see that error message right there on the screen? So, so in this case, we don't need to do this because we have a get numerator and a get denominator function. But Sometimes when you're trying to output something, you need access to the thing. Like for example, if you're going to make a stack is a data structure that holds data like this. And normally the stack only has the top element accessible. But like if you're going to print a stack, you probably want to print the whole thing. And so you need access to the private member variables, right? And so how do you give somebody access to your private members? You make them a friend. That's what you do. So what you do is you do something like this. You just copy the function signature like this. Do you guys see how that's the function signature? It's a declaration, it's not a definition. It's just the signature of the function. Like, hey, there's this function that exists, and you throw the word friend in front of it. Do you guys see that? So what this does, it says, hey, this function over there is my friend. And when you friend somebody, you give them access to your private members, okay? So this says this function has access to numerator and denominator, which are in the private section, right? So does that make sense? And so by making them a friend, you're essentially granting them private access to your member variables, okay? So numerator and denominator are private members. And so normally this would not compile because this line of code down here in the stream extraction operator is outside of the class. And things outside of the class normally cannot access anything that's private. But if you make them your friend, then you give them access to your private members, okay? So you've never seen friend stuff? Yeah, friends. Yeah, most programmers have never seen friends before, so it's pretty normal. Yeah, no, friends in real life are harder to come by than friends in programming. I'm kidding. Friendship is magic. Just remember that. Okay, so that was our little lecture for today. So for your next assignment, I'm like I said, there's not quite enough time to go over everything I want to go over for it. You're basically going to make a fractions class, and you're going to do. And if you want to work on this over the weekend, you'll have to make a plus operator, a minus operator, reduce, times, divide. You're just going to make a fraction class. And so if you've done it already, you're probably most of the way done. So the upshot being that you can end up with code that looks like no, that's my actual answer. Like this. So you can end up with very, very clean, very pretty looking code. You just see out. You can see out a fraction. You can see into a fraction. You can add fractions together, and they just behave the way that you think they'll work. Because there is no fraction class in C++, I think. There's various libraries you can use that have fractions in them. But I'm going to show you guys what it's like to create an ADT, an abstract data type. So it's a class that has private member variables, and then it's got operations on it like adding and subtracting. So it'll behave the way that you think that fractions should behave. And then you'll see the difference between CSCI 40 and CSCI 41. In CSCI 40, we do things like what Mr. Selway did. We just kind of code it up in main. And in CSCI 41, you can do things like this. In CSCI 41, the brains are in the class. In CSCI 40, the brains are in main. In CSCI 40, the brains are in main, like Selway's code. And in CSCI 41, we tend to write code where all the heavy thinking is in the class. It's here. It's in that class. Okay. It'll probably be due next Friday. Yeah, it sounds about right. If you guys want, I'll try to hack the assignment together tonight, and I'll put it up so you can start working on it. But it's basically going to be what I just told you. Okay. So I'll get that up, and then we can just talk about it in the lecture on Monday. Yeah, that works too. Okay. So that's our lecture for today, guys. Thank you for coming. Mr. Selway, thank you. Same partners? No, this will be an individual assignment. The partners thing was there so that you get support on your first assignment. There's lots of, like I said, there's lots of tutors available. There's lots of help center available. You might notice that I was helping people like 2 o'clock in the morning. I was trying to go to bed early last night. That didn't happen. Almost 4 a.m. Yeah, I know. I had actually planned on going to sleep at about 10, and then I realized that students would be working on the homework at the last minute, so I stayed up till 4 to help you guys, and then got up at 10. Okay. Do we have to have this assignment 100% working? No, probably not. You can probably just code it from scratch. Yep. Do we have a lecture on Monday? Oh, yeah, Monday. Yeah, no lecture on Monday. So we'll talk about it on Wednesday then. But it'll be the same assignment, just more C++y. So you'll do operators. Okay. All right, cool beans. All right, thanks you guys. Peace out. We got IS50B ready to rock. So we're going to be doing some computational geometry. Convex holes.